Ooh. Today's programme is all about tan, but I didn't think the Maths for Real budget was going to stretch to a week in the sun in Tanzania or Tangiers, so I've come prepared with my bottle of fake tan.
Not that kind of tan, this is mathematical tan, the tangent ratio. You know, it's all to do with the sides and angles of right-angle triangles.
Yeah, I knew that, I'm just trying to wind you up. First up, here's Katie with some tangent terminology.
This is a right-angle triangle, and this is the symbol. The other two angles are usually labelled with a letter. The Greek letter theta is the one that's often used. The tangent ratio of angle theta is the length of the opposite side to theta divided by the length of the adjacent side, or for short, tan theta equals opposite over adjacent.
What that means is the tangent of theta in this triangle is this opposite length, which is 1 metre, divided by this adjacent length, which is 1 metre. So tan theta is 1 metre divided by 1 metre, which is 1. Now, it's a ratio, so as long as the units are the same, we can ignore them. So how does tan theta vary with the size of the angle? For this taller triangle, theta is bigger, and the tangent of theta is the opposite, which is 1.5, divided by the adjacent, which is 1. So tan theta is 1.5.
As the angle gets bigger, so does the value of the tangent ratio.
This is the Ultimate, the UK's longest roller coaster, and in the name of maths, I'm here to put the tangent ratio to the test. The first drop of any roller coaster is usually the steepest, and the Ultimate is no exception. So how steep do you think it is? What's the angle of the first drop to the ground? To work it out, I'm going to use the tangent ratio. The roller coaster rails, the vertical framework, and a horizontal line parallel to the ground make a right-angled triangle. And this triangle is drawn to the same scale. The theta is the angle I want to find. Remember, tan theta is opposite over adjacent, which is 20 centimetres over 22 centimetres. So tan theta is 20 divided by 22, which equals 0.909909. Remember that number, because what I'm going to do now is look at a bigger triangle. This time, theta stays the same. But what about the tangent? This time the opposite is 30 centimetres, and the adjacent is 33 centimetres. So, tan theta is 30 divided by 33, which equals 0.909909. So it's the same as last time. Even though the length of the sides are different, the ratio of opposite over adjacent remains the same. The actual roller coaster also has the same tangent ratio. Now I know the value of tan theta, there's just one electronic step left to determining the angle. The tangent of every angle is stored in the memory of your calculator. The trick is to know how your calculator works, because not all calculators work the same. Now, if I know the tangent of an angle and I want to work out the value of that angle in degrees, I need to use the inverse tan function, which is often above the tan button. On my calculator, that means pressing Shift followed by the tan button, which equals 42 to the nearest degree. At the moment, the steepest drop of a roller coaster is 87.5 degrees. But what's the tangent of that angle?
Is it a bird? Is it a plane? Is it a person? No, it's an angel. Probably the largest angel sculpture in the world. The Angel of the North. Definitely the largest sculpture in Britain. Sited next to the A1 in the northeast of England, it's seen by around 90,000 people a day. I'm told it's the height of a 5-storey building or 4 double-decker buses. Looks pretty high to me, but just how tall is it? A tape measure isn't going to be much good, not on its own anyway. This looks like a task for the tangent ratio, and the first step is to construct a right-angled triangle. A line down the centre of the sculpture forms one side, and a horizontal line drawn at a right angle from the base of the sculpture forms the other.
To form that line, I'm using this tape measure. At this distance here, which is 23.8 metres, my eyes are in line with the bottom of the sculpture. And if I look up to the top of the angel's head, my line of sight forms the third side, and that completes the triangle. The angle I'm looking up at is called the angle of elevation, and to measure it I use a nifty little gadget called a clinometer. And that angle is 40 degrees. This side represents the height of the sculpture. That's what I'm trying to find. This side represents the distance I was standing from the bottom of the sculpture, and that was 23.8 metres. And this angle here is the angle I was looking up at the top of the angel's head, and that was 40 degrees.
Remember, the tangent ratio, tan theta, equals opposite over adjacent. So putting in the values I already know, the tangent of 40 degrees equals the opposite, which is the unknown height, divided by the adjacent, which is 23.8. To solve this, I need to get the opposite on its own. Multiply both sides by 23.8, and you get 23.8 multiplied by tan 40 equals the opposite. Flip it around, and it's the same as opposite equals 23.8 multiplied by tan 40.
To work out tan 40, I need to use a calculator. On my calculator, I key in tan 40, which gives a number with lots of decimal places. No point rounding that number yet because I need to multiply it by the adjacent length, which is 23.8 metres. And that will give me the height of the sculpture. Now's the time to round it. To the nearest metre, the height is 20 metres. Finally, I know the height of this amazing piece of art.
It's the time of the show where we have to do some maths for real.
That's right, we're both going to answer the same question, but only one of us will do it correctly. The other will make a deliberate mistake, which you have to spot. You decide, do you tick it or trash it?
A right-angled triangle has a length AB of 20 centimetres and a length BC of 25 centimetres. Calculate the size of your angle BAC, giving your answer correct to 3 significant figures. Pens at the ready? Let's go.
A right-angled triangle has a length AB of 20 centimetres and a length BC of 25 centimetres. Calculate the size of the angle BAC. Give your answer correct to 3 significant figures.
The ratio to use is tan theta equals opposite over adjacent. Then substitute the information we already have. I've decided to call my angle X. Now the opposite, BC, is 25 and the adjacent is 20. So tan X equals 25 divided by 20, which is 1.25. Now to find the angle X, I use the inverse tan function on my calculator. So the angle is 51.3 degrees to 3 significant figures.
I use the same ratio as Jamie. Tan theta equals opposite over adjacent. And I also called the unknown angle X. But I got different values for my opposite and adjacent. This side here, AB, is the opposite, and that's 20. And this side here, BC, is the adjacent, which is 25. So tan X equals 20 divided by 25. To find the angle X, I used the inverse tan function, which gave me an answer of 38.7 degrees to 3 significant figures.
So whose working should you tick and who should you trash?
Was Jamie right to say the opposite was 25 and the adjacent was 20?
Or was Katie right to say the opposite was 20 and the adjacent was 25?
OK, I was wrong. I made a common mistake, which is to identify the sides of the triangle incorrectly. Remember, the opposite side is the side opposite the angle theta. And the adjacent side is the side next to
the angle theta.
Lighthouses have always been important for the safety of boats at sea, standing out as visible landmarks to help mariners navigate.
Today, the light at the top is turned on and off automatically. But originally, lighthouse keepers would have lived here. Their job was to maintain the beacon so the lighthouse could be seen at night, and to assist ships lost or in trouble at sea. If I was a lighthouse keeper, I'd know this stretch of coastline like the back of my hand, and I'd be able to estimate how far away a passing boat was simply from experience.
Where have you been? You should have seen the one that got away. It was a good, well, 8 foot at least. Here's the deal. I'm in sight of Katie's lighthouse.
And I've got to work out the distance of Jamie's boat from the rocks below.
It isn't exactly vital for Katie to be able to pinpoint my distance, but it is for you. That's just the kind of question you might come across in maths.
The distance of a boat at sea can be calculated using the tangent ratio.
Katie, can you get a move on with the maths? You know, it's not all fun and games out here. Starting to feel a bit sick.
Chill out, Jamie. With the help of my trusty clinometer, I'll soon have this one sorted. All I need to do is measure the angle I'm looking down at to have Jamie in my line of sight. And it looks like it's 10 degrees. Next up, construct a right-angled triangle. This time, the triangle looks like this. The imaginary horizontal line in the sky is the same as the distance between Jamie's boat and the bottom of the lighthouse. This represents the height between my eye line and sea level, and this third side represents my line of sight looking down at Jamie when I was using the clinometer. Now I know that the height of the balcony here on the lighthouse is 40 metres above sea level. Add to that the height to my eye level, which is 1.6 metres, and I get a total height of 41.6 metres. I also know this angle here, that's 10 degrees. And because I know two things about this triangle, this angle and its opposite side, I can work out the third thing, the adjacent side, which is the same as the distance from the bottom of the lighthouse to Jamie's boat.
Remember, tan theta equals opposite over adjacent. Now this time we know theta, which is 10 degrees, and we know the length of the opposite side of the triangle, which is 41.6 metres. What we want to find is the adjacent. That means rearranging to get the adjacent on its own. First multiply both sides of the equation by the adjacent, and then divide both sides by tan 10, which in this case leaves us with adjacent equals 41.6 divided by tan 10.
To work this out, I need to use my calculator. 41.6 divided by tan 10 equals the adjacent, and rounding that to the nearest metre means that Jamie is 236 metres from the bottom of the lighthouse.
So Katie, how far away am I?
236 metres.